Okay, hi everyone, another data analysis video. Still on data visualization. This time I am going to focus on pair plots using seaborn. Okay, so um, the seaborn pair plot method is a really useful way to create visualizations of the distribution of variables. And what it does is it creates a grid of multiple small plots. On the diagonals of that grid, it will show the distribution of individual variables, and on the off diagonals, it will show the relationship. It will show relationship plots between two variables. So you'll see what that means in a second, and it's kind of a really useful way to inspect multiple variables, the distributions of them at the same time. So I'm going to start by importing the usual kind of software libraries that we might need. I'm going to import pandas as PD, numpy as NP, matplotlib.pyplot as PLT, and seaborn as SNS. So matplotlib and seaborn are obviously our data visualization software libraries that we're going to use in Python. Numpy and pandas allow us to import data and manipulate it in different ways. We probably don't need NumPy for anything in this particular video, but I usually it's probably considered bad form by some people, but I usually import those so they're available should I need to use them. So I'm going to run that first cell and we'll import those software libraries. And the data I'm going to use is kind of some readily available data. It appears online, and then I think is probably available in different machine learning libraries where it's open source, and it's data in relation to tips. So this is tips from, I think it's possibly restaurants in New York or something like that. So it's a data set that contains information about how big a size a party was that were eating at the restaurant, how many people, how much the bill came to, how much tip they left for the server, the waiter, waitress. So I'm going to import that and save it as an object, a data frame object called tips, and I've got it saved as a CSV, as a kind of comma separate value spreadsheet on my laptop. So I'm going to use the pandas pd.read underscore CSV method to import that and just display the head. And you can see what the variables are there contained in this data set. So we've got total bill, the tip that they left, the sex of, I'm assuming this is the sex of the customer, or maybe the server even. It doesn't matter too much in this case, whether it's likely to be the customer, I assume, who headed up the party or made the booking, because then we've got this information about whether or not they were a smoker. The day that they ate at restaurants, I think there's like Thursday, Friday, Saturday, Sunday in the data set. The time, whether it was lunch or dinner, and the size of the party. So this person, booking made by a female, non-smoker, there were 2 people in the party, and it was dinner time on Sunday. If I run the next cell and we just look at the info for these different variables, you can see that we've got a mix of kind of objects. Some of them are obviously categorical, so sex, male, female, saved as an object, like a string object. In Python, smoker the same, a category, yes or no, I guess. Day is also categorical. Time, it's shown as an object, so it's saved that as a string. Also, and that is a category as well. It's kind of lunch or dinner is saved as, I suppose. But we've also got the scale variables. So the total bill is saved as a decimal. The tip is saved as a decimal, and the size of the party is an integer. It's like an integer value for how many people are in the party. So it looks like pandas has correctly identified the types of variables, the data type of the variables in that data frame. And there's something I'm going to do before I run the plots to create these pair plots, just to change it up a little bit. I usually just use the default white background setting, but I decided to change the style of the background for the plots in this particular video. And to do that, I've just used sns.set_style and I've specified dark grid. So that will it'll create plots that look a little bit like they're on a greyish background of the sort you see if you use something like the ggplot package in R. Okay, so I'm going to create a pair plot now using, and I'm going to use the sns.pairplot method, and in parentheses I'm just passing tips. So tips is the whole data frame object, and what you'll notice that it will create plots of the variables in the data frame that are measured on a scale, and it will kind of ignore the variables that are objects or categorical variables. If I run that, you will see it creates this pair grid, these multiple plots here, and what you should be able to see is that these diagonal elements relate to only one variable. So total bill is this one, the distribution of total bill scores. Tip is this one, distribution of tips, and the size of the party is this one, relates to the distribution of counts. These are going to be frequency counts. By far most of the groups dining were like 2 people. The off diagonals, so these 3, and they're duplicated in the upper part of the grid. These are relationship plots, so you can see what's plotted on the x and y axis here. So you can see we've got total bill plotted on the x axis against size, and that's obviously kind of discrete counts, 1, 2, 3, 4, 5, 6. Here we've got tip plotted against size on the y axis, and here we've got total bill plotted against tip. So we've got a much more continuous combination of variables here, so we get this nice scatter effect, and you can obviously see there's this kind of general upward trend. The higher the bill, the larger the tip. Okay, so that's what pair plot looks like. It plots the distribution of individual variables on the diagonals, and then these off diagonals will give you the relationship between pairs of the other variables. And as I said, it's just what it's done is it's only used the scale variables. It's not used the categorical variables by default. And what we can do is change the type of plot that's shown on the diagonal by using. So here it's presented as with histograms by default. So that's the default setting. And what we can do is change that by using this diag_kind argument. So if I run this cell here, it will create the same sort of pair grid, but rather than giving us histograms, it will give us those kernel density estimator plots, which I actually prefer as a way to. It gives us these nice smoothed out continuous idea of what the distribution looks like. I actually prefer them to histograms in many ways. Okay, so that's kind of, there are obviously lots of options with seaborn, and so that was using an argument called diag_kind, so the kind of plot that appears on the diagonals, and we can change the type of plot that appears in the off diagonals using the kind argument. So diag_kind on the changes the diagonals. Kind just changes the off diagonals. So what I've done here is that there's a choice of things we could use, but I've changed it from the default of a scatter plot to, I've asked for a regression plot, a reg plot, in this case by setting kind equals reg. And what you can see now is it's plotted those off diagonals and fitted a regression line and these shaded 95% confidence intervals, those bootstrapped confidence intervals around it. Okay, so like lots of other options. So we can also change different parts of what the plots look like in different parts of the grid. So if we have this here, we could actually change this upper part of the grid, so it presents something slightly different. And to do that, we can use this kind of map_upper. So what I've done here is I've basically saved this pair plot using tips, just using the tips data. So this plot that we've got here, the first one we ran essentially, which gave us scatter plots and histograms. And I've saved it as an object called var_plots, so variable plots essentially. And what I'm doing is I'm then taking that object and I'm using the dot map upper. And what I've then passed into parentheses, the arguments for map upper, is I've basically passed the sns.kde plot. So I've told it to take the upper part of the grid, so the upper off diagonals, and plot KDE plots. And then I've told it how many levels to plot, so 10 levels of KDE plot, and asked it to, and I've also used the color argument, so I've asked it so we can see those. I've specified that I want those to be black. So if we have a look at that, what you can see then is we've kind of still got the scatters in the bottom portion. We've got our histograms on the diagonals, but it has overlaid like that bivariate KDE plot that we can get seaborn to produce. So this is like we're looking down on it from above, and they're almost like ordnance survey type style gradients, and the closer these inner kind of rings are like high points, at highest density of points, you can see there. Okay, so that's kind of just some of the options that are available. I'll just demonstrate a few more as well. Just kind of, really simple to create and visually quite useful when you're exploring your data. And if you'll recall from previous videos, we've kind of created, we've used the hue argument that you can use with seaborn to separate out based on category, and you can do the same thing here with pairplot. So if we specify hue based on some categorical variable, this will kind of give us groups by colors essentially. So what I've done here is all I've done is called the original pairplot on the tips data, but I've specified the hue argument and I've asked it to separate out smokers and non-smokers, and it will do that based on color. Thing to note is that what you'll see is, because we're now separating based on groups, for those univariate kind of histogram distributions, it's changed to a default of KDE plots, because then it is easier to see, I think, with a KDE plot, the distribution of different groups. So you can see there, blue dots now relate to non-smokers, orange relate to smokers, and you can see there we can see that there are some differences, I believe, there. So looking at the total bill and tips, it looks like, apart from this point here, generally the non-smokers were kind of like more generous tippers in this case. Okay. Other things we can do though is, we just passed the entire data frame into this, and if you've got a lot of variables, you'd end up with like lots of multiples, and that might be not what you're after, and it might not be the easiest thing to look at and interpret. But if we're only interested in assessing certain variables, we could just pass a list of those using what's known as the vars argument. So what I've done here is the same plot, pairplot as above, sns.pairplot. The tips data, we've kept this color coding, separating the groups for smoker and non-smoker based on color using the hue argument. But this time all I want is plots for total bill and tip. Okay, so if we run that, then we will get just these 4 plots essentially. So we'll get the KDE plots relating to total bill and tip on the diagonals, and total bill and tip, total bill. This is kind of less like the inverse of that, I suppose, or the reverse of that on the off diagonals. Okay, so we're able to filter based on which variables are interested. And all I've done there is pass, remember in these square brackets, just pass the Python list with the actual variable names past the strings, so total bill and tip. But we can break this down even further, and this is the last thing I'm going to demonstrate in this particular video. So again, I'm going to use sns.pairplot, pass the tips data. We'll still separate based on whether it's a smoker or a non-smoker using the hue argument. But where above I just specified which variables I wanted. So I just said total bill and tips using the vars argument. We can actually use a y underscore vars and x underscore vars. So we can specify which variable we want as the y variable and which variable or variables we want on the x-axis. So here we're going to get two plots with tip on the y-axis and total bill and size on the x-axis. And I've also asked, say, this might be useful if we fitted some sort of regression model. We've done some sort of regression analysis. So I've specified the kind of plot I want to be a regression plot. I've added this extra argument as well in relation to height, just so the only reason I've done that is just so they're kind of a bit bigger and we're able to see that. So there you go. What it's given us is basically two regression plots showing the relationship between total bill and tip and size and tip, and it's fitted regression lines for each of the smoker groups. Okay, so I think that's a pretty cool plot. I really like that. The seaborns are really flexible and easy to use. With these one lines of code, we can create like quite sophisticated production quality plots. And there are lots more, as I've said a number of times, there are lots more options available to customize your plots, and there are lots of other parameters and arguments you can add. And if you look on the seaborn documentation on the website, and if you search on the pairplot, it'll show you all the different things you can change to create plots that you want. So I haven't demonstrated things such as changing the color of the regression lines here, passing kind of like keyword arguments in relation to the plots. Those are all things that you can do that I've demonstrated when doing other types of plots such as reg plots with seaborn. Okay, so that's the pair plot. Quite useful and a very quick way to generate these pair grids showing small multiples of plots for different, so we can inspect variables, their distribution and the relationship between them. I hope that is useful.